This is our MEC 2502 project pitch, which will give you an overview of what our design is and what the purpose is behind it. Our group members are Michael Karagianis, Garen Kleshian, Levi Brown, and Christian Galang. Our design's purpose is to sort coins based off of their value, while also detecting if a fake coin passes through the system. For this project, we will be using a photodiode, which indicates when the coin is inserted. This will initiate the cycle. The coin rests on a disc above two slots. A linear Hall effect sensor will be used to detect if a metal is inserted. The coin will first pass through a magnetic field that we will create using an iron coil with a current flowing through it. When the coin passes through the coil, the magnetic field will be disrupted, thus changing the voltage output using the linear Hall effect sensor. In the event that a non-metal is inserted, the CRVO2 will rotate the disc to expose the inner slot beneath the coin, thereby sending it to the injection bin. If a metal and presumably real coin is inserted, the outer slot will be exposed, thereby allowing the coin to continue for sorting. The coin will come to rest on a force sensing resistor to measure its weight. Once the denomination has been determined by mass, a CRVO2 motor will be used once again to rotate a disc holding all the currency beneath the mass sensor to place the appropriate coin compartment directly beneath the coin. The mass sensor is mounted on a movable rail and gives weight to allow the coin to fall in the relevant compartment. Each compartment is fitted with a weight sensor, and the total is tallied up. Both force sensing resistors detect weight by the corresponding voltage to force ratio that we will predetermine. A photodiode works by converting light into an electric current when photons are absorbed. It is a semiconductor which uses a photoelectric effect, which is when electrons are emitted when light falls on a material. A Hall effect sensor is a device that outputs a voltage based off of the magnetic field. It does this by having a current flow through a thin strip of metal. When this is placed in a magnetic field, the electrons deflect towards one end of the strip, which in turn changes the voltage output. A force sensing resistor consists of a conductive polymer, which has a changing resistance when a force is applied. Our complete materials list includes the wood to create the ramps and flaps, the photodiode, the linear Hall effect sensor, a force resisting sensor, the servo motor, an iron coil, two alligator clip connectors, a Quanser Q8 USB DAC unit, a laptop, and the wires to connect the sensors to the DAC unit. There are many applications of such a design where coin currency is used. It could be used in vending machines, where previously just size was used as a detection tool, but with our design, we'll be analyzing both its material and its weight, which will prevent fake coins from being used much more effectively. Our system could also be used at banks, where a teller would need to first detect if a coin is fake, as well as sorting the coins into their respective dollar amounts. We have our objective that we want to achieve with our system, and we can see many reasons why it'd be useful to be able to detect fake coins and sort them based off of their value. In the upcoming weeks, we will be further designing our system and evaluating our design in order to execute our objective with success. This will be achieved by testing the sensors as well as implementing them into LabVIEW.